Series test is for series that are of the form -1, that's the alternating part. That makes it alternate positive, negative, positive, negative. And then in general it's called the AN, where the AN itself is positive. So this is what's causing the alternating part. Okay, so then there's two things you have to verify. One is you have to show the limit as n goes to infinity of just the AN part will be 0. And you then have to show that the sequence AN, so the sequence of numbers, is always getting smaller. Or in other words, it's decreasing. Well, you might think, wait a second, doesn't number 1 already take care of that? Because this is saying they're getting smaller and smaller and smaller. Yes, I see what you mean. But what could happen is they're getting smaller and smaller and smaller, or in other words, the limit is going to 0. But what could happen if you don't have part 2 is the AN goes like this. It's getting smaller and smaller and smaller. And then it has a hiccup and has one big point right there. And then smaller, smaller, smaller. So then it has one big point right there. Then what would happen is all of these are nicely behaving, adding up to a finite amount. And then this says, oh, by the way, add in a 12. Oh yeah, add in a 7. And all of those big numbers would have it go to infinity. So part 2 is throwing out this possibility and saying it not only has to go down to 0, but it has to do it in a very nice, calm fashion. No craziness like this. Alright, so let's get to work for this one. For this one we need to, part 1, alternating series test, just to label my work here. Part 1 is, you don't deal with the -1 part, you deal with the function part. So take the limit as n goes to infinity of sine pi over n. So how much is pi divided by infinity? Well, since pi is a constant, if you divide a constant into an infinite number of pieces, the size of each piece is basically 0. So we've got sine of 0. And sine of 0 is equal to 0, so it passes the first part of the test. The second part, it has to be a decreasing sequence. So in other words, as you're going along, and you get to some term, AN, let's say it's at a height of this, then the next one, which would be called AN plus 1, has to be lower. So that's decreasing or going down. Well, one way you could show it is, if it's going down, what's the derivative? The derivative is going to be negative. So that's one way to look at it. You've got a function where the slope of the tangent line is going to be negative. That's decreasing. That's totally Math 3A. Or you could just show that AN is actually bigger than or equal to AN plus 1. So this one is the bigger one. AN is the bigger one. Or, of course, you could show AN plus 1 is less than or equal to the AN. Well, let's see. If I were to use either of these ideas, which is more of an algebra way to do it, and I do that for sine, that means I'm going to have, for this part, the n plus 1, I'm going to have sine of pi over n plus 1. And then I would have to prove an inequality, which means that somehow I would need to take this apart, and I don't know any trig identities for sine of pi over n plus 1. So instead, I'm going to do it this way and deal with the derivative. Show that the derivative is negative. That means that it's decreasing. So for part 2, I could say y is going to be the function sine, and you can either use x or n. Here I'll just go ahead and use x instead of the n. And if you take the derivative of sine is cosine pi over x. Then you need to do the chain rule, which means take the derivative of the inside. Well, the inside is essentially 1 over x. The derivative of 1 over x is negative 1 over x squared. Then the pi is a constant, so it would stay there. And then, let's see, is this going to be decreasing, or in other words, is the derivative going to be less than or equal to 0? Well, I could answer that straight away because you've got a negative here and you've got x being squared, so that's a negative divided by a positive, so that's negative. What about this cosine part? Couldn't cosine turn into a negative? So in here, we know that this part is going to be negative, but what about the cosine part? So cosine of pi divided by something. So if this something is very large, you've got pi divided by something very large, means the result is very small. So we're talking about a cosine of a very small number. Well, cosine looks like this. And if you're talking about cosine of a very small number, then cosine is pretty close to 1. A 0.9, a 0.8, but it's positive. It's not down here. It's not down here, it's more over here. So we've got a positive times a negative. That means that y prime is negative. Y prime negative means that the function is decreasing, and so it passes the second part. So then that means that the series we're talking about, alternating series negative 1 to the n sine pi over n, then it converges because it passed the alternating series test.